Hi, I'm Dave Eicher, and I'm really happy to be a part of this presentation talking about all these great astro subjects today. I'd like to talk a little bit about what telescopes can show you. And we have the solar system, we have the moon, the sun, planets, we have some comets, and we have some asteroids nearby. Everything else beyond those objects that are close to us in space is a so called deep sky object. That's a favorite area of mine, and I'd like to talk about deep sky objects with you today and the various types. These are great for observers, but also now for astro imagers. It's easier than ever to image this stuff with some of the new telescopes that are out there. So let's talk about the types of objects that are all around our sky. Many observers and imagers concentrate on several dozen really bright objects in the sky, but let's keep in mind that a moderate sized telescope can show several thousand deep sky objects. There are many, many objects in the sky, probably many of which you haven't seen. What are deep sky objects? Anything beyond the solar system, as I've mentioned, stars, double stars, variable stars, star clusters of all types, nebulae, and galaxies constitute deep sky objects. Factors important for deep sky observing are a dark sky, away from city lights if you can, clear weather, of course, so called photometric weather, that means it's clear enough for photometry, for measuring brightnesses, and a moonless light night if you can. Small telescopes in light polluted skies, however, can be a little bit surprising. I've done a star party from Central Park in Manhattan with the club there. You can see the Andromeda Galaxy from the middle of New York. Not the greatest spot in the world to be observing, but it's remarkable when you try what you can see in telescopes. The darker the sky you have, of course, and the larger the telescope that you have, the more you'll see because of that dark sky and the light gathering power. Many deep sky objects are relatively large, so high magnifications aren't always the best thing to do with them. They're rarely useful, in fact, unless things have a very high surface brightness. So many nebulae and galaxies are really best observed at low power, at maybe 50 or 75 times magnification. The recent trend of imaging telescope packages getting much better year by year here, some self-aligning and making imaging much easier than ever before, make capturing your own pictures of these deep sky objects, even really faint ones, incredibly faint ones, much easier than it used to be. Enjoy the showpieces, the Orion Nebula, the Andromeda Galaxy, the Pleiades, really bright, gorgeous stuff that we all like to see. But so many observers and imagers are not focusing on the thousands of other interesting objects that are out there. So lots of stuff awaits you. Well, let's talk a little bit about the kinds of deep sky objects. Double stars are the simplest kind of deep sky objects, the most basic type, if you will. This just means a pair of stars together in the sky. And of course, there are double stars and there are also multiple stars. Two types of double stars exist: binary stars, which are gravitationally bound and they're orbiting each other at the same distance, and optical double stars, which simply appear to be stars together, but they lie at different distances. Our sun is solitary, but roughly half the stars in our galaxy belong to a double or multiple star system, a little more than half. And of course, if you go back to when our sun was born out of a cloud of gas, it had lots of stars with it that have been stripped and sent on their own way as they orbit the center of our galaxy. Multiple star systems can contain three or more stars orbiting each other. Imagine the sunrises and sunsets on planets with multiple stars in the sky, the stuff of science fiction, but science reality as well. Many double and multiple stars are very colorful. They have colorful components, and so they're really cool to observe in a telescope. Alberio here in Cygnus is one of them, with a nice yellow and blue contrast. So let's go on and talk a little bit about variable stars, another kind of unusual star in our sky. Many stars are also so-called variable stars, changing their light output over time, many on regular cycles. So our sun is very slightly a variable star. It's increasing its radiation very slowly over time. Some backyard observers are entranced by following the brightening and fading light of these variable stars, measuring their light output or sketching them over days or weeks to see the changes. Many types of variable stars exist. Some vary in light output because they physically change in size over time, and others because their light is periodically blocked by either a companion star or possibly by clouds of dust. This is a sketch, a drawing made with a 12-inch scope of Mu Cephei, which is a really interesting star, very orangey, and RR Lyrae, Delta Cephei, Myra, Deneb, and many others are interesting examples of variable stars, really around the whole sky. Stars that change brightness due to their physical properties include pulsating variable stars, eruptive variables, and so-called cataclysmic variables that include novae and supernovae. So many types of these variable stars all around the sky. When we get to sort of away from stars and into more complex deep sky objects, the most basic type is the so-called open star cluster. These are clusters of young stars that are in the disk of our galaxy. They're born from clouds of gas that come together and reach a critical mass. Our sun was born, of course, in one of these clusters 4.6 billion years ago. Its sister stars, as I mentioned, have scattered around the galaxy. This is the most common type of cluster inside the disks of galaxies, and they're relatively young stars winking on as gas accretes into a critical mass. The universe is a gigantic recycling program, and this is a great example of that. Many dozens of great open clusters lie scattered all across the sky. Some of the best are the Hyades, the Pleiades cluster, dipper-shaped Pleiades shown here, the Coma star cluster, M7, the Wild Duck cluster, the Beehive cluster, and many, many others. So the second major type of star cluster is really completely different physically. Globular star clusters, so named from the globe shape. While open star clusters contain young stars, globular star clusters consist of really old stars. They accreted down and turned on as stars into these balls, spheres of stars very early in the history of galaxies. And so there are many of them orbiting the Milky Way and other galaxies. These are old stars that are far out in the reaches, away from the galaxy's disk. And they came together, as I said, very early. Some of them even predate the disk, the normal disk as we know it, of galaxies that they orbit around. Whereas open clusters contain several hundred stars on average, the most massive globulars contain upward of 1 million stars in this cluster, like the one shown here, Omega Centauri in the southern hemisphere. The members of these clusters are old. They're yellowish suns that age as old as the galaxy's disk, as I mentioned, or even older. And about 150 globular clusters lie scattered around our sky. Of course, we know of many other galaxies with their own clouds of globulars as well. Good examples of globular clusters include Omega Centauri, the Hercules cluster in the northern sky, 47 Tucana, M22, M4, M5, M55, and there are many, many other bright globulars in the sky. So a great and really enticing thing to observe. Emission nebulae, they represent a huge class of deep sky objects. There are a variety of the several types of important nebulae, meaning gas clouds. So these are clouds of gas and opaque clouds of dust involved with the gas. They inhabit the Milky Way and, of course, all galaxies, and they show up all over the sky. The primary type, as we know it here, is called an emission nebula because the gas composing them is ionized by nearby stars into emitting light, very much like a fluorescent bulb does in our house. Most of the very well-known nebulae in the sky are emission nebulae. These are stellar birthplaces where clusters are forming within the nebula here. Eventually, as gravity works and the stars wink on, they'll commence nuclear fusion, the stars, and they will blow or incorporate a lot of this gas away into the stars in clusters. Examples of this type of nebula include some of the most celebrated objects in the sky that we're all pretty much familiar with, including the Orion Nebula, which is shown here, the Carina Nebula, which is much larger and brighter than the Orion Nebula in the southern sky, the Lagoon and Trifid Nebulae, the Omega and Eagle Nebulae, and countless others. Of course, Sagittarius, as we look toward the center of our galaxy, has the greatest concentration in that area of sky of objects like this. So emission nebulae, although they may be a little bit more challenging to see in our telescopes, show all kinds of varied, interesting shapes. Another type of nebula in our sky is the so-called reflection nebula. Unlike emission nebulae, which glow, as I said, like light bulbs, they're putting out photons. The reflection nebula is composed of very tiny dust particles, and they simply reflect light toward us. So they're lit up by the stars embedded within them. In the Iris Nebula here in the northern sky, it's that central bright star you can see in this picture that is illuminating the dust around it. So reflection nebulae have bright stars embedded either directly within them or very, very close by that are lighting them up. The numbers of interesting reflection nebulae are somewhat smaller than emission nebulae, but they include famous objects like M78 in Orion, nebulosity around the Pleiades star cluster, which the stars in the Pleiades are just moving through this nebulosity in the galaxy. The Iris Nebula shown here, the Witch Head Nebula, and there are others as well. Another major type of nebula, and there are many, many of these that are really interesting to see in telescopes, they foretell the future of our own star. This is the planetary nebula. They were so named in the 18th century by the great observer William Herschel. They resembled, many of them, the disks of planets in a telescope's eyepiece. They still do, but they have nothing, of course, to do with planets. They're the end state of solar mass stars, the way sun-like stars die, including our sun in the future. So when these kinds of stars run out of fuel for ordinary nuclear reactions, they expand by puffing off a shell, and the star within them transforms into a so-called white dwarf. Some 6 billion years from now, our sun will undergo this transition and our solar system will be engulfed in a glowing shell like this that will persist for about 50,000 years before it dissipates into the so-called interstellar medium. This is a good example here, the Helix Nebula. Many of these nebulae are small enough and they have high enough surface brightness that they look nice in telescopes. They're easy to observe, things like the Ring Nebula and the Dumbbell Nebula, the Helix here, the Eskimo Nebula, and many, many others lying all around the sky. Now, not all the junk that's out there floating around in the galaxy is luminous. We already mentioned reflection nebulae. Dark nebulae are another major example of the kinds of nebulae that we see often in long exposure photos, but sometimes visually as well, because these clouds of tiny dusty grains are blocking objects behind them. So the bright objects will light up some of the dust, if you will, or the gas around the dust, and let us see so-called dark nebulae. The pioneer cataloger of dark nebulae, Edward E. Barnard, created extensive lists and his famous book about these objects in the early 20th century, about 100 years ago. Famous among dark nebulae are the Horsehead Nebula, which is shown here in Orion, near Orion's belt, the Coal Sack in the southern sky, the Cone Nebula, the Pipe Nebula, the Snake Nebula, I love these names for deep sky objects, and of course many others. So these are a bit of a challenge to see visually, but there are many that can be seen in a dark sky. They're a really fantastic set of targets for astroimagers. Then we get to some sort of specialized kinds of nebulae. One of them is the supernova remnant. Now, very, very massive explosions that result from the deaths of the largest, most massive stars are called supernovae explosions, create remnants that are visible for some time. These are stars that are about 8 times or more the mass of our sun, and they go off like a cosmic bomb, and they're visible very distantly in distant galaxies. Even they're extremely bright for a brief time. And this is the Crab Nebula here, which is the result of an explosion in our galaxy in the year 1054 AD. And you can see that nebula is expanding slowly. Even in the last few decades, we can detect that expansion comparing photos. So these stars, as I mentioned, they die like a cosmic bomb, and these nebulae are long-lasting. The great examples of supernova remnants in our sky are somewhat fewer than other kinds of nebulae, but they include the Crab Nebula here, the Veil Nebula, IC 443 in Gemini, the Vela supernova remnant, and others. So let's move on to galaxies here, because as we know, the universe contains something on the order of 100 billion galaxies, maybe more. Maybe the visible universe isn't the whole universe. Our Milky Way galaxy is one of those 100 billion. So there are a lot of galaxies out there. There are the greater part of about 10,000 galaxies that you can see in a dark sky with a moderate or large amateur telescope. Many, many galaxies to observe. However, one class is hard to observe, and those are dwarf galaxies. As with stars, the most numerous galaxies in the universe are dwarfs. Consider our own local group of galaxies. Of the closest, about 80 members of our own group that includes the Milky Way, all but a handful are dwarf galaxies. These are clouds of stars, gas, and dust that typically contain 1,000 up to several billion stars in a diameter of a few thousand light years. Unlike most normal galaxies, they do not harbor supermassive black holes in their centers. They're not massive enough to do that, most of them. Examples of dwarf galaxies in our own local group include the Sexton's dwarf, the Sculptor dwarf, Leo 1, and Leo 2. And this is the Sculptor dwarf galaxy over here, and you can see even a professional image of it from ESO shows just a rich concentration of very faint stars. Spiral galaxies, these are very familiar. The most familiar type of galaxy to most of us is the spiral. Here's a Tony Hallis image of the Andromeda galaxy, very wide field image. The formation of spirals led the motions of the gas and other material coming together leads to a rotating flat disk of stars, gas, and dust. After Edwin Hubble's realization of the nature of galaxies just about 100 years ago in 1923, astronomers believed our Milky Way was a simple spiral like this for more than 80 years. The Andromeda galaxy, the largest in our local group near us, is a spiral and stretches more than 150,000 light years across. Galaxies of this type typically contain several hundred billion stars and also a halo of dark matter that extends much farther out. Examples of spirals, excuse me, include the Triangulum galaxy, the Whirlpool galaxy, the Black Eye galaxy, the Pinwheel galaxy, the Sombrero galaxy, and many, many others. So that brings us to a variety of spiral galaxies that Hubble discovered and studied, barred spiral galaxies. They show a strong bar of material passing through the galaxy's center from which the spiral arms emanate. This is a great galaxy in the southern sky in Hydra called M83. In 2008, astronomers found that our own Milky Way is a barred spiral after thinking it was an ordinary spiral for 8 decades, after carefully mapping it in infrared light. And of course, we don't have any images of the Milky Way from the outside. That's impossible. But astronomers believe that the Milky Way, structurally, it resembles a galaxy like M83 that is shown here. Other examples of barred spirals, of which there are many around the sky, include M95, M108, NGC 1300, the Magellanic Clouds, the small cloud galaxies that orbit our Milky Way, are also barred spirals. All right. Then, for many, many years, elliptical galaxies were a mystery to astrophysicists. How do we get not something with a disk, but how does it come together and produce a huge sphere of stars that is a big, has many, many more stars in it and amounts of gas and dust because it's an enormous sphere rather than a flat disk, than with a dark matter component. So elliptical galaxies are giant spheres that contain vast numbers of stars and amounts of gas and dust. And they were really curious. And then, really, only a few decades ago, it became clear to astronomers that elliptical galaxies form from the mergers of galaxies, of more normal galaxies, if you will, that creates a less organized sphere. Examples of elliptical galaxies are many, around the sky: M49, M60, M87, which is shown here, the supergiant elliptical in the Virgo cluster, M89 and M105, among many others. Then there's a special type of galaxy as the odd nature of galaxies began to become more complicated as Hubble moved on to other astronomers classifying things in a more detailed way. Gerard de Vaucouleurs is the one who mainly comes to mind here. Lenticular galaxies, which means lens-shaped, are an unusual class of objects that they have a strong central bulge and a flattened disk, but they lack the structure of spiral arms. The Helix galaxy, which is shown here, is a good example of a lenticular galaxy, an unusual class. Examples of this include M102, NGC 2685, NGC 3115, the Cartwheel galaxy, and others. Then the final class that we'll talk about here, the most exotic type of galaxy, really, we understood this in the 1980s, really for the first time. In the 1960s, astronomers began to be really puzzled about distant objects in the universe. They discovered so-called quasars, quasi energetic objects that were they're very energetic, but they were extremely distant, quasi-stellar in their appearance. They were a mystery. BL Lacertae objects, Seyfert galaxies, all sorts of high energy objects started to be discovered by astronomers. And they didn't really understand the relationship. They thought there might be an astrophysical zoo of all kinds of unusual, strange objects. It took about 20 years to the 1980s to figure out that most all galaxies have a central black hole in their centers, most all massive normal galaxies. And the energy ejected from these central supermassive black holes give all sorts of galaxies the term active, and they create these different kinds of classes. Quasars that are very distant, BL Lacertae objects, Seyfert galaxies, all sorts of other high energy objects turn out to be active galaxies with an active black hole in the center, that are viewed from different geometries. So that was sort of the puzzle that plagued astronomers for years. Now we know that most all big galaxies have black holes in their centers. When more stuff falls into the black hole, close to the black hole, a lot of it doesn't fall into the black hole, but gets ejected out at very high velocity. And we see that kind of emission producing all kinds of strange objects around the sky. So those are called active galaxies, and they really represent these strange critters that are scattered all around the sky, many of which we can see in our amateur telescopes. M82 is a good example here. near M81, the pair in Ursa Major. This is an eruptive galaxy, and you can see with its red emission coming out from the nucleus there how disturbed this galaxy is from its central supermassive black hole. Many other examples of this exist, including quasars, like the first famous one that was discovered and written about a lot, 3C273, BL Lacertae objects, also called blazars, Seyfert galaxies like M77 that have anomalously very energetic centers, and active galaxies with powerful black holes like M87, the most massive galaxy in the closest group of galaxies, cluster of galaxies near us in space, the Virgo cluster. So that is a very quick introduction to all the kinds of deep sky objects that are out there, from simple double stars that are orbiting each other often or just appear near each other in space, all the way through clusters, nebulae, and the whole sort of menu of strange galaxies that are out there. We're in one of them, but we get to see thousands of other galaxies, many of which are very active and disturbed, like M82 here. That is a quick introduction to the kinds of deep sky objects that are out there. I know that observers in a good sky can see hundreds of these objects and enjoy them, and this is a golden era for astro imagers. Easier than ever before to get your own pictures of these kinds of amazing objects that are out there in the great big universe. Thanks for listening to me today. I will hope to see some of you and talk to you and write about things in the magazine, continuing onward. So have a great time with the rest of this wonderful presentation, and I'll see you soon.